Hi YouTubers. Okay, I'm at 2.85 volts and right now drawing constant voltage. I'm drawing 270 milliamps of current. Electrochemical oxidation of a strip of lead. I don't know if you can see it in there, it's darkening. So we start with cleaned strips of lead metal as the anode, and I do that by cleaning the lead strips. I get them from Amazon with a nylon brush. I don't use steel wool because it can contaminate. And I go through washing in warm water and then cleaning with a 1% detergent solution, water, and then finally rinsing and placing in a 1% acetic acid solution for a half an hour, and then washing and drying. It's in there with a copper cathode in the back, and the copper cathode is generating the production of hydrogen gas, and the oxygen being produced at the anode, well, yep, but you're also getting formation of lead-4 oxide, which I should say, if you reproduce this, be very careful. It's a very toxic material, but it is an important electrode in lead-acid batteries. Now, why am I doing this? Well, my students can see this is a method of generating a lead-4 oxide electrode, which can have very interesting properties as a catalyst, a catalytic surface. But what we're doing is preparing the lead-4 oxide and pairing it with a gray lead metal electrode in the standard silica gel 4 molar 6 molar sulfuric acid. Gel, silica, sulfuric acid, gel electrolyte. And what we want to do is prepare a small bench scale lead acid battery, secondary cell, and go through a few cycles of charge discharge with an electronic load device, and then study the scanning electron microscopic images. We have a new SEM on campus. And to make a long story short, you really need to have a conductive material if you're going to avoid sputter application of a conductive like silver or gold. And I'm banking on the fact that doing a few cycles will still have enough conductivity with the lead. We can begin to see formation of sulfate crystals on the surface. One of my students is working on a chemistry capstone with certain aspects of the venerable lead acid batteries. So we want to be able to capture some images of the surface so we can take a look at the morphology of the lead sulfate crystals. And it's progressing now from a dark red color to a chocolate or very dark, characteristic of a lead oxide electrode. Now, one of my students said to me, well, why don't we use phosphoric acid? It's cleaner than sulfuric. And I said, because lead phosphate is a lot more soluble than lead sulfate. And yes, there are additives and other things, but we simply want to, at the undergraduate level, begin to examine the surface of the electrodes and look for certain aspects of alteration. Thanks for watching. We'll keep you posted on the images when we get them, and hopefully this will work out fine. I could roll this up too. It's a very flexible lead foil, so I can show students how we can increase the surface area, increase the milliamp hour storage, energy storage, milliamp hours, and roll it up in a cylinder, and that might be the next project we'll work on. Thanks for watching. Bye for now. And once again, be careful if you're working with lead-4 oxide. Wear gloves, wash your hands thoroughly even after you remove the gloves, and safe research. Bye for now.